The second technique that we're going to review on how to solve a system of linear equations is the substitution method. The substitution method by name means that we're going to substitute or replace equals with equals. Now the substitution method I put here in red, this is best utilized if you have a coefficient of 1 or negative 1. So when you look at your equation in example 2, substitution isn't a bad technique as long as you have a coefficient of 1 or negative 1. And in the second equation we got a negative 1 for a coefficient of y, so a substitution method is a pretty decent technique of solving this linear system. So that's what we're going to look for. So on this they say substitute one value for another. I'm going to walk through these steps. In the key concept they have those steps there for you. I will talk to them as I do them. So we have two equations. We have 2x plus 3y equals 9. Neither of those have a coefficient of 1. As I mentioned earlier, this equation has a coefficient of a negative 1. What I want to do is I want to solve for that term that has either a positive 1 or negative 1 as a coefficient. So I'm going to solve this for y. And I would prefer to replace and solve for a positive y versus a negative y. So I'm going to move this negative y over here. So I'm going to add it to both sides. So 5x equals y plus 14. And then I want to remove the 14. So that means 5 times x minus 14 has to equal y. Now, what the substitution method means is replace equals with equals. My goal is to take this system that has two equations and two variables and replace it with one so that I get it down to just one variable. So what I'm going to do is I'm going to replace this y with what y is equivalent to in terms of x. So I'm going to replace equals with equals. So I'm going to leave the 2x the way it is. What I'm going to do is I'm going to make the replacement with a substitution for y. And y is exactly the same value, or numerically the same value as 5x minus 14, and that's got to equal 9. So what we're doing is we're taking our value for y, plugging it in for y in our second equation, or the other equation, and then we get it down to just one equation, and this is just in one variable. Once we have it down to one variable, we can go ahead and solve with our normal techniques. So we're going to distribute the 3, so that's going to be 15x. We're going to distribute the 3, and that's going to be minus, that's 12, carry the 1, 42 equals 9. We'll collect our like terms. That is 17x minus 42 equals 9. And then we're going to go ahead and add the 42. So 17x equals 9 plus 42 is 51. Then we're going to divide both sides by 3. And 51 divided by, both sides by 17, and 51 divided by 17 is 3. So our x value is 3. Well, we want to find both the x and the y value that makes this system true. So we found the x value, now we got to go find the y value. So we use another method of substitution. We know that y was equal to 5x minus 14. So y is 5 times the value of x, then minus 14. So it's 5 times 3 minus 14. That should give us 15 minus 14, where that tells us the y value has to equal a 1. So the ordered pair that represents the solution where these two lines cross is 3, 1. That's a substitution model. That's the technique that we can use. Again, if I'm going to use a substitution method, I'm looking for the 1 or negative 1 as to make this the easiest possible way for me. If I don't have coefficients of 1 or negative 1 in this equation, I'm probably going to look for another method to try.